Hey everyone, Adam Infinity here, and welcome back to Singularity Today. Today, we're diving into some of the most exciting breakthroughs happening in artificial intelligence, and I can't wait to share them with you. From creating realistic videos that seem to defy the laws of physics, to building AI systems that can understand and interact with the world in more human like ways, we're on the cusp of some incredible changes. Get ready because this is going to be a wild ride. In the research titled Fission, Rigid Body Physics, Rounded Image to Video Generation, researchers present a novel method for generating realistic, physically plausible, and temporally consistent videos from a single image. They achieve this by combining model-based physical simulation with data-driven video generation. Imagine you have a picture of a ball. Fission can create a video of the ball rolling down a slope, bouncing off walls, and even interacting with other objects in the scene, all based on the physics of how objects move in the real world. The researchers highlight that their approach produces videos that are both visually compelling and physically accurate, which outperforms existing data-driven methods. This research can have a huge impact on fields like virtual reality, animation, and gaming, allowing for more realistic and interactive experiences. Imagine playing a game where the environment is generated from real-world images or creating an animated short film that feels incredibly lifelike. In the research titled Exploring Token Pruning in Vision State Space Models, the researchers investigated ways to improve the efficiency of a type of vision model called state space models SMs. SIMs are like transformers, but they are more efficient because they have a linear computational complexity. The researchers were inspired by the fact that transformers only need to look at a small subset of the most important information tokens to make accurate predictions. They tried to apply existing token pruning techniques designed for transformers to SMs, but they didn't get good results. The researchers then realized that the way SMs work is different from transformers, and naive pruning methods disrupted the important order of the tokens. To address this issue, they developed a new method specifically for pruning tokens in SMs. This method stabilizes the remaining tokens to improve performance. They also developed a way to evaluate the importance of each token in SMs. This allows them to decide which tokens to prune while still maintaining performance. The researchers implemented their method and found that it significantly reduces computation time while maintaining performance. For example, they were able to reduce the computation by 41.6 while achieving an accuracy of 81.7 on the image and data set. This research is important because it allows for the development of more efficient vision models. This could have a significant impact on various applications such as object recognition, image classification, and video analysis. Imagine a world where smartphones can recognize objects and understand scenes even faster and more accurately. That's what this research is paving the way for. In the research titled PROMERGE, Prompt and Merge for Unsupervised Instance Segmentation, the authors propose a new method for identifying and separating distinct objects in an image without needing any labeled data. The key to their approach is using self-supervised visual features, which are learned by the model from unlabeled images. The research aims to improve the speed of instance segmentation while still maintaining high accuracy. Instead of relying on computationally expensive methods like normalized cut, PROMERGE uses a simpler strategy to group patches of pixels together and then merges those groupings to create complete object masks. The authors demonstrate that Promerge is significantly faster than previous state-of-the-art methods while achieving comparable performance. Furthermore, the research shows that using the generated masks as pseudo-labels to train an object detector leads to even better results on various challenging benchmarks. This research could impact the field of computer vision, particularly in areas where data labeling is a bottleneck, such as robotics, autonomous driving, and medical imaging. Imagine a robot that can automatically learn to recognize and manipulate objects in its environment without needing explicit instructions. This is the kind of application that this research could pave the way for. In the research titled Do-Dotty Convergence Theory for Diffusion Probabilistic Models Under Minimal Assumptions, the authors explore the theoretical foundations of a powerful tool for generating new data called score-based diffusion models. These models essentially learn to reverse a process that gradually adds noise to real data until it becomes indistinguishable from random noise. The research focuses on understanding how fast these models can learn to generate realistic data, and it provides a new theoretical guarantee showing that under relatively relaxed conditions, the generated data quickly approaches the real data distribution. This means that these models can effectively capture the true nature of the data with fewer steps. The key takeaway is that the error between the generated data and the real data decreases proportionally to the ratio of the data dimensionality d and the number of steps it in the learning process. This advancement could potentially impact the development of more efficient and accurate generative models across various fields, including image and audio generation, drug discovery, and robotics, by providing a theoretical framework for creating these models with improved convergence rates. For example, imagine generating realistic images of animals using a diffusion model. The research suggests that these models can learn to generate highly accurate images with fewer steps, making the training process significantly faster and more efficient. In the research titled Elm Language Model Learning, a data set for data augmented prediction, the authors propose a new approach to using large language models for classification tasks. This approach, called language model learning, L, is powered by a method called Data Augmented Prediction, DAP. Imagine you have a big data set of information and need to classify it. Instead of traditional machine learning models that need lots of data cleaning and feature engineering, AML uses large language models to analyze the data set like a human would. The system summarizes the data to find key features that help classify the information. It then uses this summary to find relevant data points and make a classification decision, much like a human would look at similar examples. This method allows for better context, aware decision-making, and achieves impressive accuracy. The authors demonstrate the effectiveness of the system by achieving an accuracy above 90s in some test cases. This research could lead to the development of more efficient and interpretable machine learning models, particularly in fields where data cleaning and feature engineering are challenging. This approach can be used in diverse applications, including natural language processing, image classification, and sentiment analysis. In unconditional stability of a recurrent neural circuit implementing divisive normalization, the researchers tackle the challenge of training artificial neural networks that mimic how real brains function. Traditional brain-inspired models have been difficult to train because of their complex internal workings, which are hard to control and fine-tune. On the other hand, existing neural network designs, like recurrent neural networks, or RNNs, excel in tasks involving sequences, but lack the biological realism and interpretability of brain-inspired models. This research bridges this gap by introducing a novel approach called organics, which combines the best of both worlds. It's both biologically plausible and computationally efficient. The key finding of this research is that organics exhibit remarkable stability. Think of it as a system of interconnected springs that can dampen and balance out any oscillations. This stability allows organics to be trained effectively without any need for complex control mechanisms. The implications of this breakthrough are far-reaching. Organics can now be trained to solve a wide range of tasks that require processing information over time. This could lead to advances in areas like natural language understanding, image analysis, and even modeling complex cognitive processes. For instance, this research could pave the way for creating AI systems that can learn and adapt to new situations like humans, or even help understand how memories are formed and consolidated in the brain. In the research titled Building Trust Through Voice, How Vocal Tone Impacts User Perception of Attractiveness of Voice Assistants, the authors investigated the impact of a voice assistant's vocal tone on its perceived attractiveness and trustworthiness by users. The study found that users were more likely to find voice assistants with positive or neutral tones more attractive and ultimately trusted them more. This suggests that carefully designing the vocal tone of a voice assistant can increase its trustworthiness. The research could influence how voice assistants are designed in the future, leading to more appealing and trustworthy virtual assistants for a wider range of tasks. For example, online shopping could be made more user-friendly and trustworthy if voice assistants were specifically designed to be more engaging and relatable through their tone. In from seconds to hours, reviewing multimodal large language models on comprehensive long video understanding, researchers are exploring how large language models (LLMs) can be used to understand long videos. Think of it like teaching a computer to watch a movie and understand what's happening, who the characters are, and what the story is about. It's not as simple as understanding a single image or a short clip, because long videos have lots of events that happen over time, and the computer has to remember what happened earlier to understand what's happening now. This research looks at how LLMs can be designed and trained to better understand these complex videos. The researchers also discuss the challenges in understanding long videos, like figuring out how different events are related and how to remember things that happened a long time ago. They analyze existing models and identify areas for improvement. This research could have a big impact on how we interact with videos in the future, making it easier for computers to analyze videos, understand what's happening, and even summarize them for us. Imagine computers helping you find specific scenes in a movie, or being able to answer your questions about what's happening in a long video. This research is opening up new possibilities for how we use and understand video content. In the research titled AI Patient, Simulating Patients with ARs and LLM-Powered Agentic Workflow, the researchers developed a system called AI Patient, which uses large language models and a knowledge graph built from real electronic health records, ARs, to create realistic simulated patients. This system can be used to train doctors, test new medical treatments, or even help with medical research. They tested their system on a dataset of 1,495 patients and found that it was very accurate, 94.15, in answering medical questions based on the patient's ARs. They also found that the system is reliable and readable, which means that it can be used by people with different levels of medical knowledge. The researchers believe that their system has the potential to be used in many different applications, such as medical education, model evaluation, and system integration. For example, imagine a medical student practicing their diagnosis skills on a virtual patient who has been created using AI patient. The student could see a realistic representation of the patient's medical history and symptoms, and then try to figure out the best course of treatment. AI patient could then provide feedback on the student's choices, helping them to learn and improve their skills. In the research titled Soft Measures for Extracting Causal Collective Intelligence, the authors investigate how to use large language models to automatically extract information about how people think and interact in complex situations. They are particularly interested in fuzzy cognitive maps, which are like diagrams showing how different things influence each other. Imagine a map showing how things like social media posts, news articles, and public opinion all connect and affect each other. This is the kind of thing they are trying to model. The research shows that while large language models are helpful, they still need some improvements before they can accurately extract this kind of information from text. The research highlights the need for better tools to analyze this information so we can better understand how collective intelligence works. This could have a big impact on things like understanding public opinion, analyzing social movements, and even predicting how policies will be received by the public. All right, that's it for today's dive into the world of AI research. Did you catch all that mind-blowing stuff? I know I did. I bet you're feeling pretty smart right now, and that's just from watching this video. Imagine what you could do if you actually read those papers. Seriously, though, check them out. The links are in the description. And hey, if you liked this video, remember to give it a thumbs up and subscribe for more AI awesomeness. I'm Adam Infinity, and I'll see you in the next one. Oh, and one more thing. Did you notice anything strange about this video? I'm just kidding. Well, kind of. I mean, it's like super smooth and perfectly narrated, right? Well, that's because it's all AI generated. No humans were harmed in the making of this video. You're welcome, humans. Go enjoy your free time while AI takes care of the heavy lifting. Until next time,